Two variable equations create lines. Two variable inequalities also will create lines in a xy plane. If you have equals situations, I'm going to use a solid line. All right, line like you've always done before, because all we've dealt with before in this context is equals. If you have unequal situations, you're going to use a dashed line. Okay? Dashed line is kind of like an unshaded circle, right? Solid line is like a shaded circle. Okay? So same usage. Shaded line, and we have gaps to show it's a quote-unquote open line. Right. The other thing you're going to have to be aware of is you shade on the graph either up from a line or down from the line. Okay? And the thing that's going to determine whether you're shading up or down is you look for y. If y is bigger than, if positive y is bigger than, then you're shading above toward the top of the page. If positive y is less than, shading down toward the bottom of the page. Okay? So knowing those things, then here's our process. You have a inequality situation that you want to graph. And again, I'm splitting this into two parts. So part A, we're just going to deal with one equation, two variable inequalities. Part B will deal with systems of inequalities. All right? You can do exactly what we did in skill number 20. Choose a couple x values. So let's say -3, 0, 1. Use those x values to solve for y. So when x is -3, 8 plus -6 is 2. When x is 0, 8 plus 0 is 0. When x is 1, 8 plus 2 is 10. All right, I have a couple points. Put my axis on here. I need to get up to y equals 10. 1, 2, 3, 4, 5, 6, 7. All right, so we'll count by twos. 2, 4, 6, 8, 10, 12, 14. 2, 4, 6, 8. All right. And then plot my points. -3, 2. 0, 0. True? No way. That should be 0, 8. 2 times 0 plus 8. So 0, 8 and 110. Okay? They line up nice and straight. All right, so far, same as skill number 20. This is a less than situation, which it doesn't include equals. So I'm going to make a dashed line. Okay, not a solid line, a dashed line. And then the last piece, looking at y. Y is bigger than these things, right? Y is on the bigger end of the inequality. Y is bigger than. So if y is bigger than, we shade up above the line toward the top of the page. That means here. All right, you shade the whole graph that is above the line. So that's how this works. One way to do it. Okay, make a table, plot your points, shade it in. All right, a different way that we could do the same thing, if you've already handled skill 39, then you know that this right here is the y-intercept. When we have a equation, when we have y isolated, -7 will be the y-intercept, and the number that multiplies x will be slope. So I could do something like this. the graph's going to cross the axis at -7. My slope is +1/2, which means forward 1, up 1/2, forward 1, up 1/2, forward 1, up 1/2, forward 1, up 1/2. All right. This is a solid line because we're allowed to equal. And again, y is bigger than, so we'll shade above. Right? Lots of shading to do on this graph. Oh, this. All right. And all that means, so what this shading means, the reason that there is so much shading, the reason that we've got a section shaded, all we're saying is that any point in that entire region that's shaded will make this inequality true. So if I were to pick just a random point in here, like this is 3, 2. When x is 3 and y is 2, 3 times 1/2 is 1.5 minus 7 is -5.5. Okay, the inequality is true. 2 is greater than or equal to -5.5. Right? If I picked a point on the line, we already know this point is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So 6, -4. Okay? 0.5 times 6 is 3, minus 7 is -4, equals y. So we would have -4 is greater than or equal to -4. All right? Also true because they are allowed to match each other. Right? If, on the other hand, I was to pick a number outside of the shaded region, so something down here, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. This is 5, -7. And try that. 0.5 times 5 is 2.5. Minus 7 is 4.5. 4.5 less than or equal to, or my bad, -4.5 less than or equal to -7. Not true, okay? This is not true. And points outside of the shaded region make that inequality false, okay? So again, the idea of we shade things that x and y are allowed to be together is still in place for this. All right, one more example. This one, y is not isolated. So for this, your options would be either mess with the situation to isolate y, which would mean subtract 3x from both sides, and then divide by 4. All right? 4y is greater than 8 minus 3x. Y is greater than 8 minus 3x over 4. All right, that's one way to handle it. Or again, you could create a table of values, choose your x's, and then mess with the y to make the situation work out. Since we already isolated y, I'm going to choose some x's and make a table. So if x is 2, 8 minus 6 is 2, divided by 4 is 1/2. If x is 4, 8 minus 12 is -4, divided by 4 is -1. If x is 8, 8 minus 24 is -16, divided by 4 is -4. All right, let me pick one more just so I don't have to deal with the decimal. If x is -4, 8 plus 12 is 20, divided by 4 is 5. All right, plotting these points. 4, -1, forward 4, down 1. 8, -4, forward 8, 3, 2, 4, 6, 8, down 4. Backwards 4, up 5. Okay, again, we don't have an equals component, so this has to be a dashed line. All right, we're not allowed to equal things on the line. And again, y is bigger than, so we're going to shade above. Okay, so that's the situation. That's the means to doing this. Hit pause on this next one, try it, and then check yourself against what I do. All right, you might have made a table. I'm going to use slope-intercept form. I'm going to subtract x over 4 from both sides, so we got y is less than or equal to negative x over 4 plus 9. That means my intercept, my y-intercept is at 9. My slope is 1 over 4, negative. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Y-intercept. Slope. Forward 4, down 1. Forward 4, down 1. All right, y is allowed to equal it, so we'll have a solid line. Y is supposed to be smaller, so we will shade underneath. All right, and that is graphing two variable inequalities.